guys! Today we're going to be finding the greatest common factor, or the GCF. We are still in our new unit, which is Unit 6, Ratios and Rates. But in order to reduce ratios or to find equivalent ratios, we're going to need to know how to find the greatest common factor. So hopefully this is a review, but if not, pay attention. Here we go. So, what is the greatest common factor? Today, as I said, we are going to learn about greatest common factor, or GCF for short. The greatest common factor is the largest or the greatest factor that two numbers have in common. To factor a number means to break it up into numbers that can be multiplied together to get the original number. So, for example, factors of 2. I'm going to think about what two numbers can I multiply together in order to get 2? Well, the only two numbers that we can multiply together to get 2 are the numbers 1 and 2, because 1 times 2 equals 2. So the factors of 2 are 1 and 2. So let's talk a little bit more about what a factor is. So remember, to factor a number means to break it up into numbers that can be multiplied together to get the original number. So let's talk about the factors of 4. 4 is going to be our original number. Let's think about the ways that we can make the number 4 using multiplication. So I'm going to think about, how can I make the number 4? What two numbers can I multiply together to get 4? Well, I know that 1 times 4 equals 4. And I also know that 2 times 2 equals 4. There are no other numbers that I can multiply together to get 4. So the factors of 4 are 1, 2, and 4. So let's practice. This asks, what are the factors of 12? So we're going to think about all the numbers that we can multiply together to make 12. The best way to do this is to start at the number 1 and continue counting up until we reach the number 12. So when we're thinking about whether or not a number can be multiplied by something else to get 12, what we're really doing is we're coming up with the multiples of that number. So what I mean by that is, let's start with number 1. And I know that 1 times 12 equals 12. So that's our first factor. 1 and 12 are our first two factors. Now I'm going to think about how many times 2 goes into 12. So what that means is 2 times what equals 12. So I'm going to think about the multiples of 2. We have 2, 4, 6, 8, 10, 12. So I'm counting that, and that is 6. So 2 times 6 equals 12. Now I'm going to think about 3 times what equals 12. The multiples of 3 are 3, 6, 9, and 12. So it's 3 times 4 gives us 12. So far our factors are 1, 12, 2, 6, 3, and 4. I'm going to put a little circle here because this is important, and we're going to come back to this later. Because now I'm starting to repeat numbers. We already had 4. We had 4 right here. And I know that 3 times 4 equals 12. So that also means that 4 times 3 equals 12. Then if I were to think about 5 times what equals 12, I think about the multiples of 5, and I get 5, 10, 15. Wait a second. 12 isn't in there. So 5 is not a factor of 12. 6, we already said that 6 times 2 equals 12, so we know that. But 7, 8, 9, 10, and 11 are not factors of 12. And I know that because if I were to do the multiples of those numbers, I would never get 12. So the last one is 12 times, and we said that 12 times 1 equals 12. So we're going to pause on this. I'm going to go to the next slide, and we're going to sort of review what we just learned here. So the factors of 12, we determined that we can multiply all of these numbers listed. If you notice, I've highlighted a few of those because we know that 1 and 12, 2 and 6, 3 and 4 are all factors of 12. These here below are also factors, but we've already listed these numbers above. If it says here, if we were to create a table of all the factors of 12, we have 1, 2, 3, 4, 6, and 12 listed. That's all of the numbers here. We don't have to write them more than once. We only write them once. So, some things you may have noticed. So you may have noticed the following. Number 1, once the numbers started to repeat, you have found all the factors and you can stop. If we go back to the slide where I put that little circle, our numbers started to repeat here. We started to have 4 and 3 again. We had 6 and 2 again. And we had 12 and 1 again. So when you're finding the factors of a number, once the numbers start to repeat, you've found all the factors and you can stop. The second thing that you may notice is that the number 1 and the number you are factoring are always factors. So we're factoring 12 here, and 2 of the factors were 1 and 12. When we were factoring the number 4 back here, 2 of the factors were 1 and 4. So that's one thing that we can always think about as well. So let's try another one right now. So it says find the factors of 10. So like we just spoke about, we always know that 2 factors are going to be 1 and the number we are factoring. So 1 and 10, we know for sure are factors. So then what I would think about is if I were to think about, remember how in the last slide we went down the line and we wrote out all of the numbers? You can do that, and you can say 1 times what equals 10. You can do that if that helps, but you don't have to do that. You can think about it mentally, and you can say, okay, well, I know, let's go down the line. 1 was done, 1 times 10. Let's think about the multiples of 2. 2, 4, 6, 8, 10. So it would be 2 times 5, which is written here, equals 10. And then I would think about 3. The multiples of 3 is 3, 6, 9, 12. Nope, no 10 in there, so skip 3. Let's try 4. 4, 8, 12. Nope, no 10 there. And now we're back to 5. We've already found 5. So we can stop. We're repeating numbers. So we're done. So I know that 3 and 4 cannot be multiplied by anything to get 10. And once I get 5, I am now repeating numbers. So I can stop. So at the end here is the list. The factors are 1, 2, 5, and 10. Okay, one last practice one. We're going to find the factors of 8. So right now, I want you to think about what are the 2 numbers that we say that we can always use right off the bat. Think about it for a second. And hopefully you said 1 and the number we are factoring, which in this case is 8. So we know that 1 and 8 are factors of 8. Now let's try 2. 2, 4, 6, 8. That's 4. So I know 2 times 4 equals 8. Let's see if anything else comes along. So once we have 4, the only number we have left to try would be 3, because past 3, we're repeating numbers. So 3, 6, 9. Nope, doesn't go in. So we don't even need that box. So the factors of 8 are 1, 2, 4, and 8. Notice that I went in order, numerical order. So I went 1, 2, 4, 8 instead of writing it as 1, 8, 2, 4. The way that we would write this is always in numerical order. It's going up in value. So now that we know how to factor numbers, we need to find the greatest common factor. So if we're talking about the word greatest means largest or biggest. And we know that common, to have something in common, means to share something. So we're looking for the factor that 2 of these numbers share. That is the largest number. So it says to find the greatest common factor, or GCF, you must find the factors of both numbers and then circle the one that is the largest or the greatest. So let's do our factors of 3 first. I know that 1 times 3 equals 3, and 2 doesn't go into 3, and that's it. So the factors of 3 are 1 and 3. Let's do the factors of 15. So I know that 1 times 15 equals 15. Let's see if 2 works. So 2, 4, 6, 8, 10, 12, 14, 16. Nope, not 2. So I can even do that, cross it out. Let's try 3. 3, 6, 9, 12, 15. There we go. So I know that 1 and 15 are going to work. And I know that now 3 is going to work. Let's see if anything else works. Oh, we said 3 times 5, right? So it's 3 and 5. So that's it. The greatest number that we have for the factors of 3 is 3. So once I found that 15, that 3 times 5 equaled 15, I now found the largest or the greatest number that they have in common, which is 3. So the answer, the greatest common factor of 3 and 15 is 3. Let's try one more. So if we're going to find the greatest common factor, or GCF, of 6 and 18. So I'm going to start with 6, and I'm going to say that I know that 1 times 6 equals 6. And I'm going to try 2, and I know that 2 times 3 equals 6. And 4 does not. 4 times nothing, nope. 5 times, nope. So that's it. So our numbers are 1, 2, 3, and 6. For 18, I know that 1 times 18 equals 18. And 2 times, what's half of 18, I'm thinking, is 9. So 2 times 9 equals 18. And 3 times 3, 6, 9, 12, 15, 18. So 3 times 6 equals 18. And I see that our number here is 9. So I can stop when I get to 9. That's the largest, when I would start repeating. And I would think about my 8s. And 8, nothing times 8 equals 18. So I can stop here. Our factors are 1, 2, 3, 6, 9, and 18. Now, which is the one that they have in common? The largest one they have in common, because they have a few in common here. But the largest one they have in common is 6. So that would be the answer. Your task today is to complete the math games assignments. There are 10 GCF questions. You can find it on Google Classroom. Hope you guys enjoyed this lesson. You can rewatch it many times and see you soon. Bye, guys.